Okay. So the first 6 questions had you classify the triangles by their angles and by their sides. Number 1, obtuse angle there makes it obtuse triangle, and 2 sides and 2 angles are the same, so it's isosceles. Number 2, it's a right triangle, and none of the sides and angles are the same, so it's scalene. Number 3 is an acute equilateral, or you could say equiangular equilateral. I'll take either one of those angle classifications, either acute or equiangular. Just make sure you also have equilateral, because that's a side classification.
I said equilateral.
That's fine. Number 4 is a right isosceles triangle. Number 5 is acute isosceles, and number 6 is obtuse scalene. Any questions on that part? Yeah, Cooper?
I, for some reason, didn't see the congruent thing between the 2 sides of that one.
For number 5,
Yeah,
did you put
number
scalene
5.
for this one? Yeah.
Based on the looks of it.
Don't go by looks.
Yeah, go by that.
Yeah, go by the little angle measures or the tick marks. If it's scalene, it won't have any angles or any sides that are the same. The isosceles will have 2 sides and 2 angles that are the same. Number 7, this was no, it will not make a triangle because the 2 short sides are going to equal the long side, and it can't equal the long side. It's got to be greater than. It's the triangle inequality theorem, not the triangle equality theorem. So it's got to be greater than. Number 8, 4 and 9 add up to be more than 9, obviously. So this would be not only a triangle, but it'd be an isosceles triangle. And number 9, the answer was no. The 2 short sides were shorter than the long sides, so that is a big no. Number 10. The values that x could be between are 8 and 15, because if it's smaller than 8, then they will add up, sorry, if it's 8 or smaller, I should say, they'll add up to equal 15 or less than that. We can't have that. It's got to be larger than 15. But if it's larger than 15, that would make x not the long side anymore. So there was a maximum that could be. It couldn't be larger than 15, otherwise it's not the long side. So it had to be between 8 and 15. It could not equal 8. Because that would be equal to 15 and 7. We'll say we don't want it to be equal. Number 11, same deal, but I just took the 2 short sides, kind of made an inequality out of it. Your 2 short sides, x plus 6 and 3x, have to add up to be larger than 34. So x plus 3x is 4x, subtract 6 to get 28, and divide by 4 to get 7. But even though you're only adding 6 to 7 here, every time you increase x, it not only doubles, it triples it. Okay, so x could be 7. X could not be 7. Sorry, x had to be larger than 7. X could be 8, or anything between 7 and 8. It could be 9. It could be 10. It could not be 11, because if x is 11, what's 3 times 11? 33. And then actually, no, that would work. I think I meant 12, not 11.
Maybe that's not
7. Let's see. If x was 11, that'd be 33 and 17. That would work. Yeah, it wasn't 11 that I was going for. It was 12. It should be 12, I believe.
I got 34.
But what's 3 times 34? No, what's 3 times 34? Not, it's big, right? Making this side now the long side, which it cannot be. Does that make sense? Yeah, there was an extra layer of trickiness to this one, that if you made x 34, just like you did for number 10, that would work if this didn't say 3 times x, because you can't have a 3 times 34 side. Okay, so that should be a 12 there, because what's 3 times 12? 36, and that would make it no longer the long side or the short side. It would now be a long side if this was 36. So it should be 7 to 12. And if you didn't have that, go ahead and write that down. Number 12, 2 sides of a triangle measure 9 and 12 units. What are the possible whole number values for the length of the third side? Well, you never said if the third side was the short side, the middle side, or the long side. You just said the third side. So let's say that it was the long side. Well, if it's the long side, then 9 and 12 have to add up to be greater than the long side. And what's 9 plus 12? It's 21, right? So if it's bigger than 21, the long side's too big. Okay?
It has to be
And it can't
12.
even be 21. It has to be less than 21.
Has to be 12 too, for it to be the bigger side.
Because it can be the same as the big side can be the same as the little
Correct,
side.
correct, but it didn't say it had to be the big side. So if it's larger than 12, if it's between 12 and 21, it's the long side, right? If it's between 12 and 9, it's the middle side, which is fine. If it's between 9 and 12, there won't be any issues with it being too big or too small. Then if it's the small side, we run into this problem. If it's the small side, how small could it be and still be a triangle? Well, 12 minus 9 is 3. So if it's 3 or smaller, then 3 plus 9 equals 12. 3 plus 9 is supposed to be greater than 12. So it can't be any smaller than 3. In fact, it can't even be 3. It can be 3.1, it can be 3.2, but it can't be 3. So if it's between 3 and 21, we have a triangle. This one's kind of tricky because you have to think, what if X is the small side, middle side, or the long side? So 21 is the longest it could be, and 3 is the shortest it could be. Well, check that. It can't be 21. It can't be 3, but it could be any value between. 3 is too small, 21 is too big, but any value between those is good. Yes, check.
I put two equations based on like which side is the middle one. So if the X was the bigger one, I put X has to be greater than or equal to 12 or less than 21.
Okay.
And then if the 12 units was the bigger one, I put X has to be less than or equal to 12 and greater than 3.
Okay, so combine those two inequalities together. The 12 is consistent on both of them, right? Take the 12 out, and now you've got X has to be greater than 3, but less than 12, or less than 21, and you're good. Yeah, so you have it, it's fine. It can be 12. Both those say it could be 12, right? Yeah. What's up, Cooper?
The next one, are those the only two that it could be?
These are the only two that it can't be. There's no such thing as a right equilateral triangle, and there's no such thing as an obtuse equilateral triangle. Because if it's equilateral, it's also equiangular.
Like, can't there be not an equiangular scalene and an equiangular isosceles?
Sorry, when I said 3 angle and 3 side, I was referring to acute, right, and obtuse, and scalene, isosceles, and equilateral. Those are the 3 I was referring to on each of them. So I wasn't even using equiangular as one of my options. But if it's equilateral and it's right, that means all 3 angles are right. You can't have a triangle that's that big. Okay, yeah, it ended up turning into a square without its 4th side. And then an obtuse equilateral can't even be that either, because again, you have to have all angles being equal if all the sides are equal, and they can't all be obtuse angles. They have to be acute. In fact, they have to be 60 degrees. Yes.
I don't know if you would, but if you were to ask this on a quiz, would you count off if you had those two, but you also have the equiangular isosceles?
No, I would make it more. I would probably specify exactly the angle and side relationships I was looking at, so that equiangular never came up. Yeah. And these were both kind of challenging questions, to be honest. So maybe number 12 a little bit more than number 13. Flip it over to number 14, or on the back side, number 14, you're determining whether there could be many triangles with these features, one unique triangle, or not even a triangle at all. And so with number 14, that one's a no, because if you add the 3 angles together, you'll get 220 degrees, and triangles have 180. So this won't even form a triangle. Huh?
I forgot what the SAS.
Side, angle, side. So if you have 2 sides and they give you the angle between the side, it's unique. We'll look at that in just a second. I'll show you that picture I should send you guys on Friday, Thursday. Number 15, a triangle with one angle measure of 60 inches and 1 4-centimeter side. I do have a side, I do have an angle, but I need side, angle, side. And so I could draw many different triangles. It said how long this side had to be, and it said this had to be a 60-degree angle, but it never said how long the blue side had to be. And so I could keep messing with that and still meet these requirements, and I could draw many different triangles like that. Okay, so in order for it to be unique, it has to be a side, angle, side. You have to have 3. You can't just have 2. Number 16, a scalene triangle. That means none of the sides are the same, with a 3-centimeter side and a 4-centimeter side. So the answer here is many. So as long as the 3rd side is between 4 and 10, you're good, but it can't be 7. Why can't it be 7? Caleb,
You already have a second shift in your side,
and what's wrong with that?
and then they would be
It would be what?
the same way.
Okay, and what happens when two sides are the same?
There's only one.
What do you call a triangle that has two sides are the same? And it said this had to be scalene, yeah, so it couldn't be 7. And the reason I didn't say it couldn't be 4 is because we knew it couldn't be 4 anyways. Because if it's 4, what's 3 plus 4?
7.
Yeah, it has to be bigger than 7. So it couldn't be 4 anyways. It had to be bigger than 4, but less than 10. I used the same thing I did on the front page where I said, what if it's the big side? Well, 10 is the max. What if it's the small side? Well, then 4 is the min. And it can be anything in between. So if it's the medium middle side, it's fine. And then it just can't be 7. So yeah, I guess the answer there is many different triangles. Number 17, you have an isosceles triangle with 2 4-inch sides that meets at an 80-degree angle. The side angle side theorem says that that one's going to be unique. There's only one triangle I could draw like that. I can rotate it and reflect it, but it's the same triangle. So if I gave you those restrictions and I gave you a protractor and a ruler, you'd all draw the same triangle. Your triangle might be pointing up and hers is pointing sideways, but it's the same triangle. Number 18, an isosceles triangle with 2 2-inch sides and 1 5-inch side. Well, based on the side theorem, that's the only triangle I could draw like that too. All of our triangles would be exactly the same.
Okay, I thought we were doing, okay, I thought I did this whole thing wrong, because I thought we were doing like 2 plus 2 equals 4, and that's not greater than 5. So I put no.
Oh, hold on, you were right. Sorry, I didn't even pay attention to the dimensions. I was like thinking side theorem. No, you're right, Ashton. Get a sucker out of the jar. I'm glad that you caught me on that because yeah, although if I do have 3 sides, I should be able to draw a unique triangle. This one I wouldn't be able to because the 2 shorter sides have to add up to be larger than the long side. So this one is absolutely no triangle.
I have that in my face. That's a lie.
Okay, number 19, a right triangle with 3 congruent sides. We just said on the front side of the paper that triangle doesn't exist. You can't have an equilateral triangle that has 3 right angles and 3 sides are the same. You can't have 3 right angles. So if all 3 sides are congruent and if it's equilateral, all the angles would be 60 degrees, not 90. Okay, number 20. The missing angle is 135 degrees. We know this angle is 35 because these 2 are vertical. So this is 35-degree angle. And the exterior angle theorem says that exterior angle is going to add up to be the sum of these 2, which makes that 135. But if you didn't know that, you would have added these together to get this and then subtracted it from 180 to get that one, right? And then you would have subtracted that from 180 and you're back to 135. So you could do that, but it's extra work. Why it's wrong. Number 21. I know 84 and 36 makes 120, and then subtract from 180, and that makes this angle up here 60. But since this is complementary, these 2 angles are complementary and add to that right angle, I know the other angle is 30, which then if I do 30 and 86, that gives me 116, thank you. And then add that to 64, subtract that from 180, I should say. You'll get 64 degrees for your missing angle. Okay, so there's like 3 or 4 steps on that one. And then the last one, number 22, is 137-degree angle. This angle is vertical from the 45-degree angle, so it's 45. 45 and 60 makes 105. Subtract that from 180, you get 75. These 3 angles add up to 180. They're not supplementary, though. Why?
Because there's no right angle.
Supplementary.
Oh, something is.
How many angles can be supplementary, Uche? 2. Yeah, and there's 3. So you just say they would add to 180. That's all we can say about it. So I add the 75 and 68 up, subtract it from 180, I get 37. And then the exterior angle theorem yet again says that exterior angle is going to equal the sum of the 2 non-adjacent, so not touching this angle, sides, and that's our angles. That's going to be 37 plus 100 is 137. Again, if you find out what this angle is, and then subtract it from 180, you're back at 137. So you can do that as well, but you can take the shortcut and skip over it. Questions on the second page? About everything you see on this worksheet is going to show up in some way on tomorrow's quiz. The only thing that I will probably do more of is make the finding the interior angles. Right, we didn't really do a whole lot of finding the interior angles other than down here, and then finding exterior angles will show up in there a little bit more. But a lot of stuff here is going to be on the quiz. Throw in the alternate and exterior and alternate interior, parallel lines crossed by a transversal, and now we're cooking. Okay, so we're going to review all that stuff right now with our practice
So this
quiz.
is gonna be on the quiz?
Yes. Which part? The one mini or no triangles? Yeah, there's going to be some questions like that on the quiz. It is on big. Well, I think. Okay. Well, it may not be on big ideas. I'll have to post it on big ideas, but I've got the questions here on my iPad. So what I need you guys to do is a blank sheet of paper out. You don't want to do it on big ideas? Okay, then we don't have to do it on big ideas. I will have to post it for the online kids so they can see the questions better. Actually, they can just watch the video, right? Ah, that'll be my way of knowing who's watching the videos, if they turn it in or not. Yeah. Jace is getting called out by Devin. Jace, I'm sure watches the videos.
Yeah, I'm sure and they will only know Devin said that if they did watch the video. So Devin will ask them when they come back if they heard him say that.
Okay, get out a blank sheet of paper. I won't put it on big ideas, but that means you have to follow along. Title it Practice Quiz 1, or you can put 3.1, 3.2. Those are the two sections that are going to be covered on the quiz tomorrow. Yeah, to both.
Dylan, you're saying you wanna lick in my sock and I please sucks? Is that what you're saying?
What?
What?
This is getting too intimate for me. Are you what? Yeah.
Today or tomorrow?
You'll probably have time to do it tonight.
Oh, man.
Let's go. Loyola going all the way out.
All right. You guys have a blank sheet of paper out
Yes.
with your name on it. First and last. First and last. Okay, let's get started then. Today's date is the 15th, March 15th, 2021.
This month is flying.
Mm-hmm.
Like last year, this month took forever.
Well, then again, we were virtual.
Well, yeah, I know. I just feel like it took forever.
Yeah, all these lessons from here on out were all online last year, videos, and it's funny because this is all new material. So I think a lot of kids ended up struggling. The ones that didn't like watch the videos, of course, they ended up struggling in it because they didn't know what they were doing.
It was so dumb.
It's a lot of vocab. It's a lot of vocab, and if you don't do it, then you don't know what the vocab words are. What?
Learning new stuff sucks because like we can ask questions,
You did.
and if you email, then you're not gonna get an answer back like super quick.
I tried to be on it. I tried to email back right away, but
Yeah. We did like one thing a day. It was like for like.
all right, let's not. I'm sure they have their stories about some students that weren't doing their work at all. So
I'm like, maybe we'll.
number 1 says use the figure to find the measure of angle 1 and the measure of angle 2. Over there. Yep, piece of paper up there in the top tray. So let's do angle 1 first. Yeah, we're going to do angle 1 first. Any special relationship between the 46-degree angle and angle 1? No, not a special one. So if it's not vertical, corresponding, alternate interior, or alternate exterior, then it must be what, Caroline? Supplementary. They're going to add to 180. There's only 2 different angle vectors. All of them are going to be 46, or they're all going to be what?
134.
No,
360.
140.
180 minus 46 is what? Thank you. Okay, I should have had everyone saying that.
I said that.
So they want you to find the missing measures. So that's our indication that we need to label with a degree symbol. So angle 1 is 134 degrees. Now, I am going to ask you on the quiz tomorrow, what's the relationship to the given angle? And Caroline said that they are supplementary. Even if it's not one of those special ones, we can still say that you get your answer by subtracting from 180. And so they're all either 134 degrees or they're all 46 degrees. There's 4 of each. So let's move on to angle 2. Angle 2 is what, Caleb?
46.
It is. And what's the special angle relationship between the 46-degree angle and angle 2? That is correct. And the abbreviation for that, ALT, INT. Now, angle 1 is interior, but it's not on different sides of the transversal. So here's your transversal. To be alternate interior, you have to be on different sides. And remember, if you're alternate interior, alternate exterior, corresponding, or vertical, all of those are congruent. So if it doesn't look like it's congruent, then you know it's supplementary. If it looks like it's congruent, it's one of those 4. And if looks don't tell you, then try using math and figure out if it's equal. Number 2, are you ready for number 2?
Yes.
Okay, number 2 wants us to do it again, but this time we got to do it 4 times. So let's start with angle 1. How big is it? Dylan? Good. It's 113 degrees. What's the special relationship?
They're the same.
Yes, and what do we call that? Alternate interior, alternate exterior, corresponding, or vertical. Corresponding is the word. Yeah, corresponding, just like you would match up angles in 2 similar triangles, and those angles would be equal. Then corresponding angles, corresponding means it's the same angle, but on the other line. Just like if I was looking at 2 triangles, the same angle, but in the other triangle. That's what corresponding means. You can abbreviate it or you can spell out the whole word if you want to. Number 2, what's the measure of angle 2 then? Cooper.
Whatever 180 minus 113. is,
Okay, why don't you tell me what that is?
Which would be 67.
67 degrees, okay? And so you said you had to subtract it from 180. So what kind of relationship is that giving us?
That is a. No, it's not. No, it's not.
They add to 180?
Supplementary.
Supplementary. Yeah, if it's not congruent, it's supplementary. So we might as well fill out number 3 while we're at it because it's the same angle and it's also supplementary. It's vertical from angle 2, which is why angle 2 and angle 3 are the same because they're vertical. But its relationship to the given angle is that it is supplementary to the given angle. And then number 4. So we got these 3 done. Number 4, what is it, Ashton?
113.
And what's its relationship to the
Alternate exterior.
alternate exterior from the given angle? They're both, so let's look at angle 4. You can see that they're outside the parallel line, so they're exterior, and they're on alternating sides of the transversal, alternate exterior. Dylan,
Wait, do we have to write like?
Mackenzie Reed, please come to the office.
do I have to write what?
Isaiah Watson, please
Yes,
come
you
to
need
the
to write
office.
that. Yeah, if you haven't been writing the relationship, make sure you write that down.
Come to the office.
Because if you only put the angle measure on the quiz tomorrow, you only get half the point. It's going to ask you for both. Did everyone do that for number 2 as well? Number 2 was supplementary for angle 1 and alternate interior for angle 2. Write the angle relationship down. I'll go back to it if you need me to. Number 3, some true false questions here. So let's title our first question A. If the measure of angle 2 is 65 degrees, we fill it in so we can track what it's saying. If this is 65 degrees, then the measure of angle 5 is 65 degrees. True or false?
False.
No, the measure of angle 5 would be 180 minus 65. It wouldn't be the same. So that one is false. So you can say A is false. Oops, don't highlight true when I say false. There. B, if the measure of angle 3 is 74 degrees, then the measure of angle 6 is 74 degrees. Why?
Alternate exterior.
Okay, so I want you to put true, and then I want you to write that angle relationship then. Alternate exterior. or you can abbreviate. Okay. Letter C, if angle 4 is 113 degrees, then the measure of angle 7 is 67 degrees. Does that add to 180? Because they're supplementary, right? Okay, so then put true, and then SUPP is the abbreviation for supplementary. They should add to 180. I already say bye-bye. D, if the measure of angle 1 is 100, then the measure of angle 8 would be 80.
Not true.
False. Yeah, false. That one's false. They are alternate exterior, so they should be the same. Okay, but that's false. They should be the same, not different. Not supplementary. Number 4. What's that noise?
I have no idea.
You hear it?
It's like a whistling. Maybe so going to.
It's Caleb.
Number 4. Shh. Again, write down A, B, and C and D. So for part A, number 4, it says angle 1 and angle 5 are, there's angle 1, there's angle 5. What are they? New check. They are corresponding. So the abbreviation for that is CORR. Angle 1 and angle 5 is the same angle, but on the other line. And that's what corresponding angles are, and they are congruent. So they would be the same size. Okay, now put B. It says angle 2 and angle 7. Alternate exterior. So ALT-EXT for B. Am I going too fast? That's good. C says angle 6 and angle 8. 6 and 8. Yeah, no special relationship there other than they would add to 180, so they are supplementary. So I guess we're going to put none of the above, but just put supplementary off to the side because that's what they really are. There isn't going to be an option on the quiz tomorrow that says none of the above. You'll have to choose supplementary if they're not equal. Now, can supplementary angles still be equal?
Yeah.
Yes, if they are both 90, which is, so if you have two perpendicular lines, then all of your angles measure 90. So the supplementary ones are also congruent, but normally not the case. And then D says angle 4 and angle 5. Angle 4 and angle 5 are what? Alternate interior, inside the railroad tracks on different sides of the road crossing there, the transversal. So they are alternate interior angles. ALT-INT is the abbreviation. 10. No, you don't have to. No. Number 5. Shh. This is what you're going to need to do on your quiz tomorrow. Okay. You are going to need to set up an equation to solve it, not just do a bunch of side work. So AJ, what would the equation say? Absolutely. You sure can. So x plus 20 plus 114 equals 100. That could be your starting equation. You could go ahead and combine your like terms. AJ, what's 20 and 114 make? Yeah, so if you wanted to start right here at this level and say that this is your starting equation, that's fine. But I do want you to set up an equation when you solve it. One of the reasons for that is because there's going to be a lot of equations on the iLearn test. And although I know you can just take 180 minus 134 and get your answer, I want you guys to get that equation mindset again, because we don't have another equations chapter before the iLearn test. This is my way of reviewing that with you, so I don't have to add any extra assignments to your guys'.
Is iLearn exactly the same as iStat?
Not exactly, but it's.
Because the
Aaron
iStat.
Wilson's like, we're gonna get rid of Island, but then you add, or I said, now it's Island.
It's gonna be a lot like the test you took when you were in 5th grade.
I read.
Oh, that was the worst.
That was iLearn. Dylan. Yeah, what do you get when you subtract? Okay. Now we're just going to put 46, x equals 46. Notice it said find the value of x. It didn't say find the measure of the missing angle. Do you see the difference? When it says measure, it's looking for degrees. Okay. Sure, if you put 46 degrees, I'm not gonna say you're wrong. Okay. I just said no, I would not. But you don't have to write it. The reason you wouldn't have to write it is because sometimes they put like a 2x there. And so once you find x, the measure would actually be twice as much. So if it says find x, then you're good to just leave
And
it as
also,
x.
there's a degrees above the x right there, so if you just found x, you'd be able to plug it in, and you're good.
True. Number 6, find the value of x again. Now, what's this equation going to look like? Caleb,
4x plus 3 equals.
how many x's?
3x.
There you go.
3x plus 3.
Okay, equals, sure. So if you want to simplify it, right? If you didn't want to simplify it, you'd have x plus 12 plus x minus 9. But you can combine your x's to get 3x. You can combine that 12 and negative 9. It is a negative 9, so it is going to give you a positive 3. AJ, what do you get when you subtract 3 from both sides? Okay, and what do you get when you divide by 3? So x equals 59. Okay. So you see what I mean? Like, we didn't have any questions like that on our triangles worksheet where you had to like set up an equation to solve for the missing degree, but you'll have like something like that on your quiz tomorrow, just like this one here. Number 7, you're finding an exterior angle. Now, the exterior angle theorem says you don't need to know what this angle is. We just need to know what the non-adjacent, adjacent meaning next to, non-adjacent means the ones that aren't next to it. And I do know both of them. The exterior angle is equal to the sum of the two non-adjacent angles. So x plus, what's the other angle? 90. So move that x over to the other side by subtracting x from both sides. How many x's will that give you on the left side? 3 of them. And so what's x equal to? Sorry, you're right, it's not our answer. X is equal to 30. It wants to know the measure of the exterior angle. So if x is 30, then Ashton, what's that make this angle? 120. Times it by 4, and it said measure, label it with the degree symbol. The exterior angle is 120. So we have a 30, 60, 90 right triangle, but the exterior angle is 120 though. Number 8's the same thing, but number 8 uses 2 different variables. Okay, 2 different variables. We have to solve for x and y. Okay, so I have to set up an equation to solve for, it says write an equation for the value of y in terms of x, and then solve the equation for x. So for the value, it says to write an equation for the value of y. So what is y equal to? Someone other than AJ or Muche or Ashton or Caleb or Dylan. Is y an interior or exterior angle? Claire?
Exterior.
Okay, so the exterior angle is equal to what?
That would be y equals x plus 40.
There you go. So write down in this first blank, x plus 40. What Claire is saying is that the exterior angle is equal to the sum of the two non-adjacent interior angles, which is the x plus 40 there, okay? It says then solve the equation for x. So yeah, that means get x by itself. So how do I do that, Harrison? Yeah, subtract 40 from both sides and you'll have x by itself. It'll say x equals y minus 40.
Wasn't that just in slope intercept form?
The first one was,
Yeah.
this one's not, because it's solved for x and not y. Let me make sure real quick, that's all they want you to do. No, there isn't any way you can solve it. You could say, well, hang on a second. I have 2 different equations with 2 different variables. Why can't I solve this? Because it's one equation is just a different form of the first equation. You really just have one equation here.
Plus, you'll
Can't
get
you
one
find
number.
what x equals and then put it like third? You can't.
No, because we don't know that third angle.
You could do 2x, because that's x2, right? Oh, no, never mind.
Not necessarily.
Not the same, yeah.
Yeah, if they told me what this angle was, then I could tell you what x and y both are, but I don't know what that angle is. So that's the only answer. Y equals x plus 40, and then rearrange it, and you get x equals y minus 40. It's a variation of the same equation, so I can't even use systems of equations to solve for it. Number 9. The figure shows a truss used in the construction of a building. The measure of angle 1 is 39 degrees. Find the measure of angle 2. Okay, well, what we have here is we have two parallel lines crossed by a transversal. So what's the special angle relationship between angle 1 and angle 2, Levi? They are congruent, but that's not the name of it. What do you call two angles that are inside the parallel lines and on different sides? Alternate interior. So the measure of angle 2 is 39 degrees because they are congruent. That's correct. But what we're going to say is that they're alternate interior. Yeah, putting congruent as the reason of why they're equal will not fly on tomorrow's quiz, just so you guys know. Okay, like I want one of those special relationships. Don't tell me that they're equal because they're equal. I want to know they're equal because they're alternate interior. Okay, so just so you guys know on the quiz. Number 10, find angle X, which happens to be an exterior angle. And sorry, Grandma, but I need to zoom in over here. We see that this is a right angle. So how many degrees is that? 90. And we see this angle is 85. And the exterior angle theorem says that this angle is equal to the sum of the two non-adjacent interior angles. So I don't even need to know what that little tiny acute angle is. Devin, what do I got here for X? Yeah. Which means that's a 5-degree angle on the other side, but I didn't need to know that. I don't need to put degrees either because it never said, no, it does say, it says in degrees in the instructions right there. Okay, so 175 degrees. I would have said just put X equals because normally it says find the value of X, but then it went out of their way to say put it in degrees. So X is 175 degrees. There is a law, actually, I think each state has it's either a federal law or state law that when you're building a wheelchair ramp that it has to be a certain, can't be more than a certain angle measure because it's not, number one, it's not safe. Number two, it'd be too hard to wheel up the ramp. So I'm not sure exactly what it is, but
my grandpa used to have these metal things that it was like a metal slab and we had to put them everywhere he'd go, like to get up steps.
to get up steps
Yeah, instead of
in a
like-
wheelchair.
Yeah.
Okay. So he was able to use the wheelchair up the steps
Yeah.
instead of,
Like
well,
not many steps, but like a couple steps.
yeah.
Yeah.
Well, there was a law passed back, and I'm sure it was like the 60s or 70s, but basically it said every new building that was being built had to have handicap access. And so all the buildings now that we see, most of them have wheelchair ramps at somewhere. And a lot of the places you go have even, handicap accessible parking as well. So Caleb,
Is that why wheelchair ramps are so steep, or not steep, like
long?
long?
Yeah, because if you can't go over a certain angle, like I could, if I was trying to wheel up onto my desk, I could make a ramp that starts here, but it'd be really steep. If I start at the door, then I can ease my way up to that level. Yeah.
I don't think Grandma's gonna make it, 'cause she's just got her hands like this, she's just gonna roll.
Now I think about it, unless she's got the brakes on, she's probably rolling backwards because her feet aren't on the floor to stop her, on the ground to stop her. And she's got her arms crossed. So there's a good chance Grandma's going backwards down this ramp right now. So,
She's being pushed by it this whole way.
all right, you guys have paper copies. Okay, come bring them up and turn them into the tray. You guys email me paper copies when you finish. That's today's lesson.
Hi, Max.
Hi, Jason, even though you're not there.
Hi, Jason Camden.
I believe that you're there, Jason.
Yeah, when your papers turn to the tray, you can use the restroom.
Max, remember